get going here. Actually, first I want to start off, maybe Omar, you pasted the link of the minutes and agenda into the chat room. Do you see my comment in that chat room, or do you not see it because you joined after I made it? It's basically the same link to the agenda.
Oh, I didn't see it because I joined after, I think.
Yeah. Oh, okay. I'm just curious how GoToMeeting works.
Yeah, so maybe paste it again, Scott or Omar, just since we had a couple more join in the past minute.
There it goes. Thank you, Omar. Okay, so let's get going here. First of all, welcome everybody. And so we're just talking about, if you just joined, there's a link in the chat of the GoToMeeting with the agenda for today. Go ahead and bring that up. It's a Google Doc, and you can put your name in there just to let everybody know who attends. It's always good to see who we've got on the call. And also, your company gets, or your organization gets credit for you attending these things as part of your OCP membership. Couple of pieces of news. The first one is that we had SK Telecom had a design. Their TCAP spec is now accepted by OCP, and so we thank SK Telecom for their contribution. It's always great to have these switches that get contributed, accepted by OCP, and go through the entire process. So thank you very much to SK Telecom. The second piece of news is that, yeah, I don't know really how to say this, but so the project leader elections are in process, and the time period for nominations has closed. And for the networking group, our group, there were only 2 people nominated. That was Omar and myself. And so you are stuck with us for another 2 years. There's no need to have an election since only 2 people were nominated. And so we're going to be the project leaders for the next 2 years. There was one project, I believe it was a telecom project, where there was multiple people nominated, and so they are having an election. And if you are a member company, you should have gotten an email. And if you didn't, you can contact either Michael or Archana at OCP and ask to get a ballot. And you should be voting now. I think it's closing pretty soon, actually, the voting period. So that's the only project where there was multiple people nominated and had a need for an actual election. Next thing is the OCP regional summit, and that's going to be in Amsterdam, as we've said before. If you submitted a talk that was accepted, or even if not accepted, you should have gotten information about that. If you haven't, then please contact either Omar or myself if you don't know the status of your contribution. You should have gotten an email, and you should have submitted an initial presentation already. And we're going to have one of those, well, not the presentation, but one of the presenters is going to talk in just a minute here. Any questions about the regional summit or any of this news? All right. So let's continue on with the next item, and that is that we are going to have a networking project workshop. And this is scheduled for the end of August, and we've put the date August 29th. That's the date that we're going to do this workshop. We're still putting together the agenda, and we're going to get a place, which is most likely going to be in the Silicon Valley somewhere. And so I just wanted to put this out for right now, for everyone to put that on your calendars, reserve that date. And of course, we'll use the email alias to send out more information. and OCP will send out, their own announcements and so forth. If you are a member company and you'd like to host, please reach out to either myself or Omar or Archana at OCP. Again, your company will get credit for hosting an event and help you in your membership. We typically have somewhere between 75 and 100 people at these things, so we'll need a space that can hold about that many people. Any questions about the, I know there's not a lot of details, but questions about that?
I just have a statement that overlaps with the open source summit up in Vancouver, so I won't be available.
Ah, okay. Yeah, we try to not schedule these things that conflict with other things. Unfortunately, I think no matter what date we pick, we're going to conflict with something. Let me just throw that out there. Is there going to be a lot of participation in the open source summit? And should we pick a different date?
Well, one thing we can do is we can just put as part of the follow-up from the meeting in the notes, we'll broadcast out to the list and get a sense of who else might be attending or have conflicts that week.
Right.
Yeah, in case not everybody, so certainly everybody who usually would attend may not be on this list or on this call.
Okay, we'll send out an announcement and get some feedback after the meeting to the mailing list. Okay, so we'll then get into the two presentations we have today, and I'll make a presenter. Who should I set to present for Cisco's open networking presentation? Is that Omar?
No, you can actually make me the presenter. I'll have the presentation ready. Yeah.
All righty, and who is me?
Oh, this is Akshat here. Sorry.
All right. Hold on a second. There we go. All right, I think I just made you presenter.
Okay, so just give me a second. It seems like I need a plugin.
Of course.
Okay. Oh, maybe it's working. Can you see my screen?
I can, yes.
Okay, excellent. All right, so I know we have about 15 minutes. So what I'll try and do is the presentation is actually an excerpt from some of the things that we'll talk about at the regional summit later on into the year. And as part of that, there are multiple pieces. I know some of those would be fairly obvious to the community here, so there's no necessary need to actually repeat those. But I will touch upon some of the integrations that iOS XR, which is Cisco's stack on the service provider platforms, has dealt with over the last few months as we've started integrating with more and more of the OCP technologies in the service provider sphere. And as we do that, I'll touch upon the integration points as well as some of the sort of the lessons that we've learned, as well as some of our feedback on how the integration went and things that may be potentially improved, and definitely try and present to you where we are at today. So just for some context, I'm Akshat Sharma. I'm a technical marketing engineer in the service provider BU within Cisco. And we handle iOS XR and its relevant technologies within the service provider sphere. And I also have Sandesh Rao on the call with me. He's a software engineer who's been working on the integration of iOS XR with the OCP technologies. And he will actually touch upon a lot of the integration details and some of the feedback items later on during the talk. So without further ado, this is, as I mentioned, this is an excerpt from the actual presentation. And I'll only touch upon a few of the slides because you only have about 15 minutes. Hopefully have around a few minutes for any questions from the community if needed. All right, so let me go straight into the evolution that we've sort of had with iOS XR to try and just showcase how we've approached this disaggregation story for iOS XR over the last few months. Or in fact, to be frank, this is something that's been in the making for the last few years. But the way we've approached disaggregation has been a very incremental approach, primarily driven by a lot of the service providers that we work with as customers. And therefore, the first step that we took almost 4 years ago with iOS XR primarily transforming to provide APIs at various layers of the stack. And in doing so, our focus was to disaggregate individual layers of the stack so that we can start pretty much accessing different use cases that customers have within the service provider space with their own controllers and state machines and agents and so on. And if anything, this was sort of our first foray into the idea of slicing up the network stack so that we can start integrating with individual technologies from the ecosystem. And of course, some of these agents and controllers, etc., are not necessarily part of the OCP ecosystem, but they are part of the general white box community at large. Even if you consider open source protocols such as OpenR, for example. And we consider this to be as much a part of the overall ecosystem that we need to integrate with. And hence, slicing up the architecture of iOS XR so that we can integrate at higher layers of the stack was equally important for us. So the initial disaggregation that we went through with iOS XR was something like this, right? So more of a monolithic architecture that we used to have maybe say 5 or 6 years ago to a much more sliced up API-driven architecture that allows us to integrate with different agents and controllers within the service provider and general open source community stage. And as part of this, one thing that is absolutely clear is that our focus on treating the software infra as a monolithic piece that basically we deliver as a vendor NOS was fairly intact over the last several years. The focus was primarily on the higher layers of the stack being sliced up rather than the infrastructure layer itself that could allow us to integrate with different types of hardware or actually have a shot at figuring out what the platform integration cycles would look like with white box hardware if we were to do that. So the next obvious step would be to look at the software infra layer at the bottom, and which is primarily on the right hand side as I'm pointing here, and try to slice that up to see what are the useful integration points for us as we proceed towards integrating some of the white box hardware within our ecosystem of iOS XR. And much of this, of course, stems from the requirements from several customers that we've dealt with over time, and the level of flexibility that they deal with, that they require within the service provider space, which includes integrated platforms from vendors, but also some white box hardware. It is what primarily drives this integration cycle for most of us as vendors. And therefore, the next slicing up, as you can see here, was primarily at the infrastructure layer, where we started looking at the hardware abstraction components, looking at where the platform integrations will take place, where the optics integrations will take place, etc., and try to see if we can not only provide an extra API, hopefully at the hardware abstraction layer that becomes useful for the community, and that's something that we are currently continue to work with. But while doing that, the actual integration points with white box hardware that we will have to deal with needs to be as clear cut as possible, so that our integration cycles with white box platforms over time can be significantly reduced in the amount of time that it takes. So as showcased on the right-hand side, the software infrastructure layer gets sliced up into the hardware abstraction layer, along with capabilities that allow us to create adaptations that are relevant to the community or on top of the ASIC SDK as needed. And the system OS and BSP generally represents all of the platform integration pieces in totality, but I'll touch upon those in a slide in just a bit. So yeah, so this is what our evolution primarily looked like, and therefore the structure on the right-hand side pretty much represents what the network stack of iOS XR today looks like when we have to deal with integration, whether it's with integrated platforms from Cisco or with white box platforms within or outside the OCP community. And therefore, getting back into the actual integration points, this is probably a more simplified view of the same architecture I showcased earlier. And now iOS XR within itself, of course, contains all of the components that do platform management today on integration platforms. And that would include things like fans, sensors, LEDs, etc. And optics, although considered pretty much a part of that inventory management infrastructure, we tend to talk about it as a separate entity, primarily because of the amount of integration work that goes into enabling optics on the system, and also how we potentially like to approach its integration going forward as well. And Sandesh can talk about that in just a bit as well. And as you can see, there are three primary layers, although I've not really highlighted the HAL piece. It is an equally important component of the integration cycle, where the platform modules that you see at the bottom as part of the BSP layer, as we indicate here, are the ones that we typically leverage from the community directly. So the ODM vendors would publish their own the modules typically in the ONL Git repo, which is where we generally extract these from, and then are able to compile it into our own sort of BSP layer that becomes a part of the overall NOS. And the platform abstraction, the optics abstraction pieces are part of the iOS XR architecture that deal with the integration of those platform capabilities exposed by the underlying platform modules. And again, we can do it in a variety of ways. We select the most appropriate technique based on the amount of integration work that we need to do to make things work. And I'll touch upon that in just a bit as well. The reason I've not highlighted the HAL piece in this case is that typically that integration is the part that takes the maximum amount of time compared to the platform integration piece. And therefore, since we already support several merchant silicon within our integrated portfolio, it is fairly simple for us to support a new white box platform if it falls within the same family of ASICs that we already support. If it doesn't, yes, the integration cycle becomes longer, and then we deal with it on a case-to-case basis. So this is kind of what the integration architecture overall looks like. I won't go into details of all the individual pieces, but I'll just quickly touch upon them before I hand it over to Sandesh for a couple of slides. The idea is that there are generally 4 decision stages whenever we have to deal with customers when they are looking to deploy white box hardware within their environments. And typically, of course, the first step is the actual selection of the hardware. And generally, we work with the network integrators who could be either from our side or a third party, or the actual network operators themselves, who tend to choose the hardware based upon the port density and the ASIC and platform capabilities that they might be looking for within their environment. Yes, being OCP compliant is something that we would prefer because it helps us leverage things from the ecosystem, especially the ONL modules that are published in the Git repos. And once the hardware is selected, we tend to integrate with the platform. Again, can be done in multiple ways. We select a particular technique where we expose the platform module capabilities which are compiled into the kernel directly as SFS parts that we can integrate with in the network stack. And some of the pieces of ONLP are also leveraged, though not as much in the current integration cycle. The optics abstraction piece is also a piece that takes a fairly significant amount of time as part of the platform integration cycle. We will quickly touch upon what we expect to change within that area. And integration with the ASIC is fairly obvious as well. Generally, a combination of either the ASIC SDK coming from the vendor or from the customer, or something like the OpenNSL library acting as an open API. This is usually a vendor decision or a customer decision based on how they want to deploy it and what their requirements are around licensing and so on. And of course, creating an installer image is equally important. ONI currently is the installation bootloader paradigm within the OCP community, and therefore we adhere to that by creating a corresponding ONI compatible installer image. The docs here have been super useful, so that definitely helps us clear out the hurdles around creating a compatible installer image. And white box devices, as they would in any other scenario, would download and install an IOSXR image, an ONI compatible installer image of IOSXR via DHCP server, and then boot up as they would on in any other scenario. So the actual workflow in terms of bringing up IOSXR mimics what you would typically expect any other NOS to do within the environment. The differences tend to appear after the NOS is up and running based on the capabilities that it has. So to therefore quickly touch upon the OCP integration pieces that we have today, I mentioned some of this already. Currently, IOSXR leverages the vendor modules that are published in the ONL Git repo. These have been specifically useful for any of the newer OCP or not yet OCP compliant hardware that some of the customers that we deal with have been speaking about. And we tend to expose these capabilities as sysfs parts once the modules are compiled into the kernel, allowing some of our platform integration abstraction pieces within IOSXR to directly leverage these parts and gather the data as needed. And there are, however, certain write capabilities within ONLP that allow us to leverage the existing capabilities, such as, for example, handling fan speeds based on temperature sensor data, which tend to be very specific to the platform that we're dealing with. So we leverage the existing capabilities of ONLP to do something like that. And whereas most of the read capabilities, as I mentioned, get directly integrated based on the ONL modules that we've compiled into the kernel. And of course, there is a lot of great documentation on all the individual projects, so that definitely helps us a lot in making sure that this integration goes through smoothly. So in terms of the feedback, I'll let Sandesh actually talk through some of these pieces since he's been closely working on them, and we can stop for questions.
Hey, so I mean, this is based on what we have done as we have integrated it in a couple of devices, and this is our general learning. We kind of work with the vendors to see what can be done about this. So one of the things we found is if you need to introduce some new type of optics, there needs to be changes at ONLP and vendor optics module, because I think some of the things are quite, some of the things are based on some assumptions of some types of optics being present. I know that there is an OM project where you're trying to enhance this, but we would like to see how it will come together with the ONLP. I think the next one is a bigger issue for us. Most of our software, we tend to do it based on eventing, and currently it doesn't look like there's any way to get events for different hardware actions. So, for example, if an optics is plugged in or plugged out, we don't get notifications. Similarly for fan speeds or even the thermal sensors, right? So this is another area where we think there can be more different infrastructure that can be built in. And the last one is we are finding the data that we get when the PMC is present, not present, varies across vendors. And this is another area where we can, if there is a more of a uniform layer that the NOS can access, I think it'll kind of help with the integration. The other thing is we wanted to understand whether there are any test scripts that are present for ONLP. This is another area where I think it could take, where there could be more focus so that there's more uniformity again across different vendors. Yes. Akshat, is there another slide beyond this?
No, it's pretty much it. Yeah. Right. So thanks, Sandesh. I think that's pretty much it from our side on this meetup. There is more stuff, including demos that we can share as we will do during the regional summit. So if there are more questions, we can certainly pause here, and of course open to anything later on as well outside this meetup.
Yeah, hi. This is Aviad from Elonox. I was wondering, have you looked into Psi instead of defining yet another layer, although it's yours, the OFA?
Right. So in terms of the current integrations that we have, as I mentioned, a lot of this is dependent on integration cycles that we have to deal with when customers approach us. So currently we already have an internal abstraction layer that does a lot of the stuff for not only the merchant silicon, but also for our own integrated silicon. And therefore, as a result of that, moving away from that to Psi would be both problematic for us in the short term and also would sort of reduce the capabilities that the abstraction layer currently has. So we haven't thought about moving to Psi. However, having said that, the API that we have currently enables us to create adaptation layers that can mimic Psi behavior, which is how we're looking to approach this, so that customers, etc., who want to leverage capabilities with Psi might be able to do so on top of our existing abstraction layer. And as I mentioned, this is purely a function of the capabilities that we require across our portfolio, as well as the integration cycles that it would involve.
Do you mind bringing back up the architecture diagram?
Sure.
I don't remember how many slides back that was.
So,
okay.
Yeah. Is it this one?
Yeah, no, perfect. And I didn't have a question beyond that, just in terms of as we talk about Psi or other things, and maybe able to have that up. And then, although I did have a question just to make sure. So, you were mentioning sort of the working with the ONLP abstraction layers, and I think that's with the platform abstraction on the left.
Mm-hmm.
So iOS XR is using the drivers or the modules from the ONL repo as its layer to get to the hardware.
Yeah, so Sandesh can touch upon this as well, but the idea is that the platform modules that I'm representing here in green at the bottom in the BSP layer, those represent the platform-specific modules within the ONL Kit repo that we typically compile as part of the kernel. And once these platform modules are present, the corresponding data gets, especially sensor data, etc., that we require, gets exposed through the sysfs paths in the file structure. And once that capability is exposed, we have two different points of integration. One is for the reading the data, which is what we do using the platform abstraction piece. Again, that is an abstraction piece that already exists in iOS XR today. So we continue to leverage that for reading this data. But there are certain capabilities that we would call the write capabilities, or anything that takes action, wherein ONLP, especially the ONLP daemon, can be leveraged to actually change things like fan speeds based on the temperature sensor data, where we continue to leverage the existing ONLP capabilities to do it for us, rather than trying to implement it on a per platform basis.
One thing that, and this is just actually a review for your presentation coming in
Sure.
the regional summit. One thing that might be interesting would be to annotate this diagram with, where is ONLP and ONL being leveraged? And to the previous question, this is where potentially Psi could be used, even though you're not using it right now because of the timeline requirements that your customers have. But that's where it overlaps, at least to understand, where how it complements. And then there's certain parts where, hey, we built our package. It was just done with Oni and installed with Oni.
Right. So yeah, I'll be adding more slides for that. I mean, I'm restricting the number of slides for the meetup, but there will be certain more slides that will expand on exactly where these ecosystem components will exist if integrated with the existing architecture, and also how we plan to move forward with some of the integrations. So yeah, point taken. I'll be adding those slides shortly.
And I think you probably will have the detailed ones, but just like a big picture to sort of get a sense, that would really help. Because any one of those, you could go into a lot of detail to say like, hey, this is what we're pulling out of ONLP. This is what we're not. This is
right.
So,
yeah, got it.
Okay, cool. Any other questions?
So yeah, I have a question. Oh, and it looks like someone just put this in the chat too. So I think of iOS XR as a very capable, large software system, and I was wondering if you had issues porting this to any of the OCP platforms as far as the CPU subsystem goes, the power of the CPU or the amount of memory or whatever. Were those issues, and you have feedback for that? And then also, what is the hardware compatibility list?
Sure. Sandesh, go ahead. Yeah.
So I would let our marketing publish the hardware compatibility list, because these are some internal. There's a lot of internal discussion that's happening on that. But typically we run well on the x86 variant and some of the ARM variants. So currently we have integrated it only on the x86 variants. Now, what was the other question? I forgot that.
If you have, if you found issues with, we need this amount of memory, or, these CPUs are just not up to the task, or, maybe flash.
Okay, yeah. So, diving deeper into that, the x86, some of the x86 variants we prefer to run on the Broadwell, not on the Atom, mainly because of the processing and scale requirements, some of the things that our customers have. Now, with respect to memory and other components, I think it just depends on the customer ask. So we can typically run from very low end to a high end memory, high scale application. So it just varies based on the customer ask. So based on that, I think we try to work with the vendors and the customer to identify the right hardware, which would be the CPU and the memory and any other associated components.
Yeah, and typically we have several integrated platforms that are very similar to the white box platforms that are available, including the merchant silicon capabilities that we already leverage in the integrated portfolio. So from that perspective, the support capabilities and what we expect from the platform tends to be similar. We do expect certain platforms to have low number of resources, but we have those constraints even within our integrated portfolio based on the type of use case that we're trying to handle. And therefore, in a sense, as Sandesh mentioned, we can go across these range of devices and only give the part of iOS XR that is necessary to run on it. And as for the list of devices, we are dealing with it on a case-by-case basis. And currently, if the blog link that you can see at the bottom of this slide actually will point you to details on the AS7816 Acton box that we first did the integration and showcased the demo on. We are working with some other boxes as well, and we intend to publish an entire list once we have a pool of white box devices that we've enabled iOS XR on. As of right now, each individual customer tends to come to us with their requirements in selection of the white box hardware. Of course, owing to the sort of the NDA requirements, I can't disclose exactly which platforms those are, but we will be publishing a list once we have a pool of them integrated.
Great, thanks for answering that. One of the ways that you can contribute to OCP, obviously you're not going to contribute, well, hopefully you would, but I presume you're not going to contribute iOS XR itself. But you can contribute reports, and these are sort of like, we have a standard format for it. It's sort of like a test report that verifies and certifies that this software runs on this OCP hardware. And I can send you information about that so that you can make it's a contribution and counts as a contribution to OCP if you'd be willing to do that.
Oh yeah, that would be definitely useful. We'd love to be able to at least provide our learnings and reports on what we're doing, so and get some feedback as well from the community.
Yeah, hi, this is Archana. So yeah, we call them tested configurations, and it would be great from an interoperability perspective for our, for our community that is looking at adopting, product and looking at testing that has already been compliant, right? So I think anything that you can publish that we can put on our contribution as a tested configuration or a reference architecture or anything of that sort would greatly help. It's something tangible, right? So that they can take and look at.
Yeah, agreed. So
yeah, so Scott and I can, send you more details on what
yeah, I
that
would love to get more information
like.
on that, and then we can.
Perfect.
And
thank you.
Just to clarify for particular hardware, and then maybe we should make sure to switch over. We have one more presentation.
Yep.
But did I just? I was reading the notes. It's the 7816. This is the 64 by 100 that you were running
7816, correct. It's a 64-port hardware. So all the details are actually in the blog link that you see here. I can send it as a separate link in the chat as well. So you'll find details on the hardware that we selected. It's OCP compliant and it comes from Edgecore.
Okay. Great. If other folks have comments or questions, I tried to capture a bunch of the questions that were going on during the discussion into the meeting notes. Cool. Thanks you all for presenting.
Sure thing. Thanks a lot for having us, and we'll love to engage more and get some more details on especially the reporting piece that we spoke about, and we can come back with more details.
Yeah. Okay. Thanks. Oh, and Akshat Sandesh, is this yet available? Is there a? I know this is part of the coming up presentation at the workshop, but if there are slides that we can share and post, that'd be great.
Yeah, so I'll send you this particular slide deck. It's not the complete presentation that I'll have later on, but it's representative.
Great. Thanks.
Yeah. All right. Thank you.
All right. Thank you, Cisco. The next presentation we have is about a rash of switch contributions. And Robert, I think I made you the presenter.
Okay.
If you can go ahead and share your screen. Yep, I can see that.
I see that. Good. Okay. All right. Let's do this. Put this in the corner. Okay. You roll to the first page. I'm sorry. Here we go. All right. So, okay. So I got 15 minutes, right?
Yep.
Scott? Okay. Let's put the timer. My name is Robert Zhu from Delta Network. I'm a system engineering manager, and sitting with me, I have Krishna Kolakururi. He is our hardware engineer, which is in charge of design all these switches, and also the software stack as well. So today we're going to present our OCP-inspired Delta switches. Move on. Okay, here's a brief content: introduction, product, and OCP tenets, and also open software matrix and what software ecosystem we're in, and also ordering information. So, first of all, the quick going through. Our product family basically has categorized as enterprise, data center, and the service provider. And right now, we are only on the Broadcom chips, which is Strata XGS and Strata DNS. But we are planning to expand to other chips vendor as well. It's work under progress. It's going very well. And our switches cover from 1G all the way to 100 gig. So here's our current status with OCP. As you can see at the left, the first model we have AG6248C PoE switch. That's the one that's already been as OCP accepted, and that's based on the ARM chips Helix 4, which is from Broadcom. All the way from right, starting with AG9032V1, version 1, AG7648C, AGC7648A, and AG5648V1, and AGC5648S. I'm just categorize a little bit. The AG9032 is 100 gig switch, and it's a spine switch, which is we are following the OCP, summon, which is develop our switch from the leaf switch all the way into the spine switch as OCP. We're striving hard into the OCP accepted. So this is our effort to get into the spine switch. And also in the center two, that's the 10 gig switch, but one AG7648C is the copper port, and there's a leaf switch. And AGC7648A is a deep buffer switch, as you can tell. And 5648 series are all 25 gig. So AG5648V1 and AGC 5648S is a deep buffer switch as well. And as you can tell, the ASIC is starting from, we use a Tomahawk for 100 gig, Trident 2 for the 10 gig, 40 gig uplink, and Qumran MX as as deep buffer 10 gig switch, and Tomahawk Plus as 25 gig, and the Jericho Plus as 25 gig downlink and 100 gig uplink. This is a brief specs of our switches. As you can tell, AG9032V1, the CPU, we are on the Intel C2538, and the chipset is Tomahawk, and the PSU is 800 watts. We use both AC and DC as it's interchangeable. And also the red highlighted is the next model we're going to contribute to OCP is AGC9020, and that's based on the Intel D15 Broadwell chips, and also the CPUs, and the switching chip is Jericho Plus, and we are going to deliver that pretty soon. Actually, we already have the the sample right now. So at the bottom is the 25 gig portfolio. We have the CPU 2538 and another the deep buffer 25 gig CPU is the D1548. It's Broadwell, and the chipset, and also to see the power, the PSU, and the port configurations. Okay, this one is a 10 gig portfolio. 10 gig portfolio is 7648C copper, and that's one is we use the C2338, and the AGC deep buffer switch we use CPU is C2538 originally as well, and the chipset is different. The first one is Trident 2, deep buffer is Qumran, and they use the only on the AG7648, on the AC PSU, we use 460 watts, but DC we use 550 watts. And the 7648A Qumran, that model is 800 watts for both AC and DC. So on the right side, we have the NOS, which is already running on those switches. Basically, we have the only two we're not having any interoperable tested yet on NOS is AGC 5648S, and also including the new one AGC 9020S. So okay, here's the detailed specs. I won't go over, but as you can tell, the Broadcom chips on the AG5648V1, I think the model number sometimes confuse people. The difference is that we use Broadcom, ASIC chips is the BCM56967 instead of BCM 56963. So, and this is the hardware design of the 25 gig. Okay, I just just show the audience here. Basically, this is a little bit go into the deep buffer. I want to mention the deep buffer switch. We have two TCAMs equipped. It's one is BCM 52311, 900 megahertz, and also we have 16 gigabytes GDD DDR5 4000 as a packet buffers. And as you can see, these two TCAM go with the ASIC BCM 88681 on each one of them. So AGC 7648, this is a deep buffer as well. So the last letter, we have two models. The contribution we made here is the A. The A is without Sync E, and you can order the switch with Sync E as well. Only difference is timing. Okay. So here's the block diagram for AGC 7648. This is AGC AG7648C as all the copper ports, and this one is the Trident 2. Yeah, I use the Trident 2 switching chips. Okay. Here's the design scheme, block diagram. This is a 100 gig switch. The only one thing I want to mention is, all of our switch, the form factor of the AC and DC PSU are all identical, and you can basically just swap out. It's a hot swappable. Swap out the AC power PSU with our DC power PSU as well. And also another one is the fan, the airflow directions. The default when you order our switch, the default is from front to rear. But if you prefer from rear to front, and you can order our different fan module. The fan module is swappable as well, and different fan module which is reversed from the default fan module. So So it's totally configurable, and it's totally you can choose as your choice. Okay, so as you can tell, for all these, we are after we starting the OCP for tennis. In order to cover all these four aspects, basically the common part on the efficiency side, all our PSU, the power unit, the power is more important than anything else, right, in the switch. So all of our PSU is 80 past the 80 plus gold level, and also the Energy Star 2.0 certified. And also the efficiency all above 90%, and that's the kind of privilege of the Delta. And also from scalability is as you can tell, I show you the AC and DC module, and the fan module is totally hot swappable. So you can change the power source at your will, and it's very convenient. Also, for the remote management, I'll show you in the later slide. And I want to mention that for the 25 gig models, two of them already had the BMC capability. So all the environmental management of the switch and has can use the BMC to manage those. For the openness, we for all the the software and the firmware and all the interface and the open interface APIs, we establish our GitHub, so you can get those from our GitHub. And open interface, I will have another slide later, so you can tell what we exactly have. So let's get you more clear pictures. For the impact, impact is we have Delta as a global company. We have a very strong supply chain, and you can order all the models right now and from anywhere in the world, so we can deliver. All right, so the open software environment support. The first, as you can see on the top, is our 9032 V1. We support all of the the open software as ONI, ONL, ONLP, OpenNSL, and Sonic. OpenNL is kind of open, but I count it as open. Okay, so. And also the 25 gig as well. But I like to mention that for the 5648 V1, the OpenNSL, we are working in progress, including the Sonic, and we are going to fully compatible with these two open software. And but AG7648C, because there's the copper port, that one we do not have any plan right now for those open software environment support, and but we can do that. So the others in the carrier side work, the Qumran switch and the Jericho Plus, and as you can tell, the AGC 7648A, we can support almost all of them current matured open environment, open software environment. And but the Sonic one is because the chip is not in the Broadcom support list, so that's kind of like pull our legs on doing that, and including the AGC 9020s and AGC 5648S, and but these the AGC 5648S ONL and OpenNSL is in progress right now. We are going to do that. The software ecosystem, as you can tell, there's a two routes. One is the hybrid solutions. We support the traditional protocols. You can use our switch as a traditional switch, and also you can use the SDN protocols and the open APIs. And for the remote management, we have Chip, Puppet, Ansible, and orchestration, software to manage those our switches, and also you can use the traditional one, CLI, SMMP, and syslog, all these kind of tools to do that. And so we have as you can tell, we have two sides. One is the traditional side, another one is the new SDN protocols and the open APIs. These are the compatible optics with our switch, but these are for information only. You can see this is already has a SKU, so it's ready for order. So, and that's it. Thank you so much. Any questions?
Yeah, this is Jeff Catlin. I have a couple questions. First, it's good to see all the activity, so congratulations, very good. You talked about a lot of different switches throughout your presentation. Can you just go back to one slide, maybe it's your first slide, and just indicate which 4 units you're contributing now? I kind of got lost with all the part numbers.
Yes, you see this five switch actually.
5 switches, okay.
Yeah, you see the first one we already got the OCP accepted. That's I put the logo on there, right? So
yep, okay.
And all the others is that's the 5 models we have, and we cover 100 gig, we cover 10 gig, we cover 25 gig. But okay. Yeah, we think the 10 gig we have Chrome Run MX, right, models, and we think the 25 gig we have a Jericho Plus. So.
Okay, and are these 5 new contributions you're doing? Are these for accepted status or inspired status?
Inspired, as inspired.
Okay. Okay. Thank you.
Yeah.
So just so everyone knows, if you go to the wiki for OCP on our networking site, I think I put the link in the comments there. You'll see all 5 of those switches under the currently under review section.
Yeah, like I said, we are going to strive into more ASIC chips, more choice, and also that's the direction we're going to next get into, and also into the spine switch, more spine switch to contribute to OCP.
Yeah, this is Robert. Hello?
Yes, I'm here.
Yeah, is it going to be sold under Delta or Agma?
It's Delta, but Agma is the brand right now. Okay. It's not an independent, legal entity anymore. So.
Okay, thank you.
Yeah, Agma is brand.
And then Robert, if you can provide the slides, or is this the final slides that we can post?
Yeah, of course. Okay. Yeah, I sent it over to you last week, but if you think anything, like I want you guys have a comment, right? If you have any input, I can update it and then send to you guys official one. So if you don't have any comment, yeah, go ahead and post it. That's fine.
Okay. I think we're gonna have to end the call right here, simply because we're out of time and people are going to drop off anyway. So thank you for your attendance this month. We will have another meeting next month, and of course we're going to have some stuff going on the mailing list, so keep your eye on that regarding the workshop and some of the other upcoming activities we've got. So thank you all for attending.
Thank you.
Thank you. Bye-bye.
Thank you.